Hello, welcome to Module 12, Optimizing Queries. My name is Rich Raposa, and if you've gotten this far and you've gone through each module in order, you've made it to the end of the ClickHouse Developer Learning Path that we have. If you're starting here, well, you can see where we're at. We're in the last module. Go back to the beginning and you can get all caught up with how we got to becoming a ClickHouse developer and really on the path to becoming a ClickHouse certified developer. In this particular module, in this particular training, I have two very specific topics. I'm going to start with projections. They're a great way to optimize your queries. They're similar to materialized views. They store the data twice, whether it's storing all the data sorted differently or whether it's a result of an aggregation. And I think you'll like how they work because they work at the part level instead of having to define a separate table like you do with materialized views. And then the other key topic in this module is something called a skipping index or a secondary index. Every table gets a primary index. I'm going to show you how to define another index that's built on the way your data is already stored. Your data is sorted by primary key or whatever the sort order is. You can take advantage if you know what your data looks like and skip those granules using a secondary skipping index. And so we'll see how that works as well. All right, let's get started. Let's take a look at how to optimize queries in ClickHouse. And there's different ways to do that. I'm going to start with projections. It's a very interesting capability of ClickHouse, kind of similar to materialized views. And I want to kind of give you some motivation for why you would write a projection or create a projection. Honestly, it's the same logic that we used when we did the materialized views. If we look at the UK prices table, that we've kind of been using throughout the training, but if you haven't seen it yet, here's what it looks like. It contains all the properties from the United Kingdom that have been sold, the transactions from 1995. Notice the primary key is postcode 1, postcode 2, address 1, and address 2. I don't have any idea why that was picked to be the primary key. That was how it was in the documentation. And I tell you what, if you want to know what the average price is of homes and you know the postcode 1 and postcode 2 values, look how fast that was. 3 milliseconds, only had to process one granule. That's 8,192 rows. If I want the exact same query and I don't know the postcode, so I pass in the town, that has to read the entire data set. Is it fast? Well, yeah, it's 64 milliseconds. But what was this one? This one was like 4. Like it's considerably slower. Processing one granule is great. Well, the data isn't sorted by town. Town's not in my primary key. I kind of wish it was. Well, here's what I'm going to do. I'm going to define a projection. And let me go over here to the slides because I have all this on the slides. Like I said before, a projection is like a materialized view. A materialized view is a separate table, separate schema, everything. In fact, it's a trigger, which is one schema, and then it's a table, which has its own schema. And so it's actually two separate components. And you have to know when you write the query, should I use the original table or should I use the materialized view? With projections, you don't have that problem or that situation at all. A projection lies inside the part folders of your table. A projection is a part level component. So every part's going to have a subfolder for each partition, and the data in the partition is the result of the query just on that part, whatever rows are in that part. So you got a million rows in the part, you have a partition, it'll be a query, the result of a query stored in a subfolder. What's nice about projections is you don't even have to know they exist. As the person writing the query, you're going to write the query, send it to the table. ClickHouse is going to look at your query and then decide, should I read from the table or should ClickHouse is thinking this now, should ClickHouse read from the projection? It figures out which of the two options, well, you might have multiple projections. Let's say you have 4 projections. You'd have 5 options, the table or one of the 4 projections. ClickHouse figures out which one would be the fastest. Really what it does is it figures out which one's going to have the fewest number of rows or the least amount of data to process. And so it decides at query time. Again, this is really nice. You don't have to know ahead of time that the projection even exists. Someone writing the query wouldn't even know. And I'll show you how to see if a projection gets used or not. But here's what it looks like. Now here I'm altering the table and I'm going to add a projection to UK price paid. You don't need to add a projection. You can define a projection when you create the table. I just didn't do that. So it's after the fact and I've decided later on, boy, I wish things were sorted by town. And so that's what I did. I'm altering UK price paid. I gave my projection a name. Now I'll be honest with you, the name of the projection doesn't really matter because you're not going to ever use the name. Now you might see the name when you look at the syntax and the execution plan of your queries, but you don't use the name at all. And I've decided to pick 5 columns. And by the way, this is the exact same query I used for the materialized view in the materialized view training. And I'm going to sort it by town because it wasn't sorted by town. So let's try this. Let's just run this command. Now this is a mutation. And by the way, the projection exists, but if I go back and run this query for the average price in Durham, well, it still read every single row. So that makes me think the projection wasn't very useful. Well, that's because it hasn't triggered it yet. The projection is only being applied to new rows being inserted into new parts. I could force a merge, but what we typically do is materialize the projection. You only have to do this once if you didn't define the projection at the beginning of the table. That creates a mutation. I want to show you that. Let's look at system.mutation. And you'll see that I've done some other things, but the last 2 mutations in here are add the projection and materialize the projection. And if I scroll over, the first one is done and the second one is not. That should be done by now. Let me see if my average price, yeah, it's still reading the whole table. Well, here's a little trick I'll show you. I'm going to kill the mutation. What is the mutation ID? I'm just going to grab it here. This one. So I'll just copy and paste it and let's see what happens. Let me see if that did it. Well, it didn't kill it, but it looks like it forced it to finish. I have no idea why. Here, let's try this again. Oh, this is perfect. Okay, so for whatever reason, the mutation, I don't know if I gave it a little kick or something, but it's off and running now. It exists. And like I said, your query doesn't change. This is the exact same query. Notice how many rows were processed. 65,536. Well, that looks like 8 to me. Yep, that is 8 granules exactly. Instead of 3,500 granules, ClickHouse only had to read 8 granules. Watch this. If I put explain in front of here, ClickHouse will show me the execution plan. And I have to point this out every time. The word projection here at the beginning has nothing to do with projections. It's a little confusing. But if you scroll down where it says read from merge tree, normally you'd see a table name here. But I don't see a table name here. I see a projection here. This explain command is sort of validating or verifying that my projection is getting used. And if I use explain up above, you'll see the difference. Up here, it will not use the projection. It wouldn't make sense to use the projection on this one because the primary key has postcode 1 and postcode 2 in it. Notice there, read from merge tree is the name of the table. That's nice. That's projections. They're nice. What I like about projections is, unlike materialized views, projections get updated during merges. So if I delete a million rows, not lightweight delete, but if I do a mutation delete of a million rows from a table in a part, well, when that part merges, whenever that is, my projection will have to get updated. And so there's certainly going to be some lag in terms of data, but at least they're kind of in step with the data in each part. So if I update or delete rows, eventually the projections will absorb those changes. So that's kind of nice too. All right. So that was me materializing the projection and then sort of verifying that it works. We only had 8 granules processed. Very nice. Like I said, they're stored inside the part folder. By defining a projection, now I'm storing in my projection here every row twice. And so there is a cost. When I insert a million rows, those million rows have to go into a part and then also get put in the projection subfolder. So my inserts are going to take longer and my merges are going to take longer because now I'm merging twice as much data. So I've slowed things down in terms of the back end of all the things that ClickHouse does to maintain the parts. But honestly, it's not that much different than a materialized view, which was storing the same data, but in a separate table. So give it a try. You can do more than sorting in projections. You can have an aggregation. Like here, I selected the most expensive house in town, and that's all I put in the projection. This one's really nice. I'm going to actually run this one. let's say you have a dashboard and the dashboard has the most expensive house in a town that somebody can select. Look, if I select the most expensive house in town, I have to read the entire data set. If I materialize the projection, and then I suppose I better wait for it, but this shouldn't take long. Let's see how long this takes. So the materializing this is this one right here. Is it done yet? Oh, it's not done yet, but let's see if it's done. I'll just run the query. Ah, it's done. How do I know it's done? Well, the query only had to read 1,172 rows. That's not even a granule. Where did that magic number come from? Well, if you look at the number of rows in UK price paid, or sorry, if you look at the number of unique values of town in the data set, there's only 1,172 towns at any given part. That projection inside that part, this projection right here, is only going to have 1,172 rows. So it only has to, and I must only have one part because I'd only had to read that many rows. So, all right, so max price. I love that one. It's super quick, super simple. This doesn't slow down your merges hardly at all. This doesn't slow down your inserts hardly at all because figuring out a maximum value takes milliseconds. It's super fast. All right, so I like that. Okay, let me show you another mechanism in ClickHouse for optimizing a query. The materialized views and the projections are great, but they store the data twice. Remember, in ClickHouse, you get one free index. Every merge tree table gets its primary index built off the primary key. You can actually define a secondary index. We also call them skipping index. Why do we call them skipping indexes? Because, well, first of all, they don't resort the data. So a skipping index can only be built off the existing sort order of the data. And the granules already exist. Like we already have, the primary index already has the concept of granules. So at most, we can skip granules. That's what we're doing here. The goal with a skipping index is to skip the existing granules in some clever way. And so, and there's different kinds. If I go to the docs, by the way, I have a very nice article. If you go to the homepage of the docs and you go to best practices, that second article there is on data skipping indexes. And it kind of walk through what the different types are. There's one for min and max. Keeps track of the minimum and maximum value of a column. Well, that can help you. You'll actually do that in the lab. There's a set. That's the one I'm going to show you right now. It keeps a track of all the values of a column. Nice. It works well if you have a low cardinality, value inside each granule. And there's three different types of Bloom filters. There's just a straight up Bloom filter. And then there's ones for strings, for tokenizing strings, and for creating n-grams of strings. So check the docs. Those are your options here. Just like projections, you can define an index at table creation time. Now I didn't, so I'm going to add an index later. Not an unusual thing to do. Notice here, this is a min-max index. I want to show you something. I want to type this in. I already have it typed in, but I want to run it. Right here. Oh, I need to drop the town sort projection because what I'm going to show you is kind of the town sort projection kind of already speeds things up. So I noticed something about the UK property prices table. The way it was sorted by postcode 1 and postcode 2, I noticed that there weren't that many towns, unique towns in each granule. In fact, it was really common for a granule to only have one value of town. So what I'm going to do on the UK property data is I'm going to create a set skipping index. And what the set contains is all the unique values of a column. I'm going to pick town. And so it'll have, like in this first granule, St. Albans is the only value of town for all 8,192 rows. So my set's only going to have one value in it. And then what I'm trying to show in this second granule is that there's two unique values of town. Harpendeck and Wellwyn. So I'm going to put those in the set. The skipping index will keep track of those values. And even in the whole data set, I don't even think I had a granule that had more than 3 unique towns inside of it. Here, Hatfield, Bath, and Wincanton are all in the same granule, so they'll be in the set. And so you can imagine what that primary index is going to look like. So let's give it a try. And I have it defined here. So I drop the projection right here. That's the name of the index. Call it whatever you want. This is the column that it's going to build the index on, and I picked set. Now the 10 is kind of a safety mechanism. 10 says, all right, don't store more than 10 towns in each set, in each values of the sets. And granularity is an interesting number. I put 3 there. That's not 3 rows, that's 3 granules. That's 8,192 times 3. That's about 24,500 some rows. That's how many rows I think I can skip here. And so that's what I'm going to build it on. Don't get confused and put 8192 here. Whatever number you put there, the number of rows you're skipping gets multiplied by the granularity of the table. All right. So I created the index, but of course it's not going to exist right away. So I need to materialize it. So let me materialize the index. And let's look at this query up here. I don't know why I have that setting there. I'm going to take that setting off for a second. Let's run the query and see what happens. Okay, it's running it's processing every single row. So let's do a select star from system.mutations. And let's see what's going on. I added the town set index. I materialized it. Yeah, that one's not done. I'm going to try and kill that mutation, which I can steal the code from up here. Yeah. Let's see what happens if I kill the mutation. For some reason that seems to have triggered the process here. Let's run my query again. Let's just see what happens. That definitely did something. Instead of reading all 28 million rows, all 3,500 granules, it's 319,488 divided by 8192. It processed 39 granules instead of 3,500 granules. Not bad, considering that I didn't store the data twice. All I'm storing in memory are these values. It has to be in memory, of course. It's just like the primary index. All the secondary indexes fit in memory as well. That's nice. By the way, if you put an explain command in front of that, let me explain that, and you set index is equal to 1, ClickHouse will show you, whoops, I spelled that wrong, index is equals 1. It's reading from the table, so I'm not using a projection. If it uses the primary key, that's the index for the primary key, it has to process all 3,514 granules. If it uses the town set index, which is a skip index, which had a granularity of 3, it only has to process 39 granules. That's perfect. By the way, that'll always be a multiple of 3 because that's how I've set this up. The way I defined it with a granularity of 3, I'm guaranteed to process at least 3 granules. But of course, I'm also skipping 3 granules at a time. So not too bad. And it still processes 8,192 rows at a time. Nice. Hey, I'm very happy with how this works. And so that's great to see. I got all the queries here on the slides where I materialized the index. And like I said, you can verify that it worked. You can actually force a skipping index, but I just used the explain command so you could see how that works. Hey, make sure you understand how skipping indexes work. If you build a skipping index and you only skip, it's only like a 10 or 20% savings in rows being processed, it might not be worth the overhead. And make sure you don't build a skipping index that's consuming a massive amount of memory. It's important to understand the overhead of the index. Make sure that the index offsets the cost of your queries being faster. And of course, you can always use a better primary key. You can always use a projection or materialized view. But I think in this example, in this particular data set, creating that town set index on town, just knowing what the data looked like is perfect. I don't have to store the data twice here and sort by town. This skipping index is doing a lot for me. And so I'm super excited about how that worked out. All right, change of subjects. We're going to sort of end this conversation with some anti-patterns and some best practices. So the anti-patterns don't necessarily flow together in a topic, but I just want to go through them. In ClickHouse, an anti-pattern is to have too many parts. Too many parts can happen if you don't have enough resources, enough memory, enough disk space, enough CPUs available so that merges can happen in the background. Okay, that's one problem. And the way to solve that problem is to obviously scale. Throw some more resources at your cluster. The other too many parts scenario comes up is poor user design. You didn't partition by month. You partitioned by some other value. There are some off use cases where partitioning by another value is okay, but not if it generates too many parts. It's very important. Make sure you're using async inserts. Too many small inserts can create too many parts. Or you might just have too many materialized views. You insert the data into one table, you got 10 materialized views. You're just generating 10 times the number of parts. And so keep that in mind as well. ClickHouse has a maximum. After you hit 100,000 parts, ClickHouse assumes that something wrong has happened and it'll start to throw errors. All right. This is an interesting sort of maybe not common thing that's done nowadays, but in ClickHouse, scaling horizontally too early is actually an anti-pattern. We recommend you go vertical first. If you can fit all your data onto one machine, then don't shard your tables. Scaling horizontally means sharding the data. Well, if you have, I don't know, you have 1 petabyte of data, which let's be honest, that's a massive amount of data, and you can fit all that on one machine, do it. Get a big machine, get terabytes of RAM, get hundreds of cores. Don't just shard your data because you're used to sharding data in these big data frameworks. ClickHouse is one of those interesting systems where having everything on one machine is great because ClickHouse uses all the resources. So don't scale horizontally unless you absolutely have to. So that's an anti-pattern. Just like we talked about in that lesson on deduplication and updating and deleting data, a lot of mutations with things like alter tables and lightweight deletes and lightweight updates, those are mutations as well. All of those add up. And too many mutations is an anti-pattern in ClickHouse. Like, why are you doing that is sort of the first question we always ask. Are you using ClickHouse properly? And second of all, if you do have to do it, consider replacing merge tree, consider collapsing merge tree, consider client-side deduplication if your application can allow it or some ingestion system that you're using can do it too. All right. I didn't talk much about some of these complex types, nested, tuple, map, JSON. They're all great. They're fine. They work fine. Well, except for JSON. We're actually working on a better implementation of JSON. But there's a cost with them. So yeah, if you have to use them, use them. But if you don't have to use them, if you can do some clever change in your ingestion scheme and your design of your tables, then it's nice to avoid things like nested and tuple. And of course, nullable, in one of the earlier chapters on data modeling, I explained how nullable adds an extra column to your table for each nullable column. And so that costs you something. So make sure you're using nullable only when you need it. And that would be business logic. One of the most popular anti-patterns we see is a poor primary key. This almost always happens because somebody doesn't know ClickHouse. They're using Postgres or MySQL and it's slow. And they're like, hey, let's try it on ClickHouse. So they take the exact same table definition from Postgres or MySQL or whatever, and they copy and paste it into ClickHouse and find out that their queries, yeah, they're probably faster, but they're not awe-inspiring faster. Well, because the primary key is such an important decision. Make sure you pick columns that you filter on frequently. Make sure you don't put too many columns in your primary key. And if you do have multiple columns, make sure you sort them by cardinality in ascending order. So put those low cardinality columns first. You'll skip the most number of rows right out of the gate. We just talked about skipping indexes. I mean, at some point in time, you might get too excited about them. You might have too many of them. Those Bloom filter ones are okay, but man, it's hard to get a Bloom filter to skip the number of rows that I skipped with my set index on the town set index that I created. So keep that in mind that, make sure the skipping index is worth the cost of it. This one comes up once in a while. That limit doesn't necessarily speed up your query, especially if you have a group by or if it has to grab a bunch of data. You can set optimize aggregation in order to 1 with a limit, and then it'll shortcut the query. But look, I do this all the time. I'm like, oh, I got 1 trillion rows, which I have absolutely done before. I'll just grab the first 100. And then I realize that my query did something weird with the sort order, and all of a sudden it's processing 1 trillion rows anyway. So anyway, just something to be aware of. We talked about this when we talked about materialized views. They're really popular. They are widely used in a lot of situations, especially dashboards where you're running the same computation over and over again very frequently. They're great. Just understand that if you are deleting and updating data, first of all, ask yourself why. And second of all, beware that the materialized view doesn't catch up with that. Now, for what it's worth, I'm going to go to the docs and I'm going to Google this because I want you to see this new feature called refreshable materialized views. Now it's experimental, so you're not going to use it yet in production, but keep an eye out for this. When this does go live, this could be something useful for you where when you do change rows in the source table, the materialized view will actually go back to the source table. Right now, materialized views do not touch the source table ever. Something to be aware of. All right, so those were some anti-patterns. Let's look at some good patterns. Let's look at some best practices. Make sure you use dictionaries when you can, or the join table engine. Go back, and if you didn't go through that join training that we have, we talk about the different algorithms. Using dictionaries with joins is a great, performance optimization, or the join table engine, like I said. Floats are not accurate. That's an operating system thing. It's got nothing to do with ClickHouse. If you need accuracy, even if you don't need accuracy, look, there is a decimal data type in ClickHouse. If you go to the docs, under data types, where are my data types? Right here. Decimals right towards the top. There's no loss of precision. They store decimal types as integers, and it's just more efficient. There's almost no reason to store a value as a float in any capacity. Keep that in mind. Make sure you understand how projections work. They are wonderful. They look good. They sound good, but they cost something. Like in this example where I'm storing the data twice. All I did was sort the order in a different manner by town. That's going to cost me. Every merge, every insert's going to be slower. So always important to understand how those work. There are some data types for special things. We have a data type for UUIDs, universally unique identifiers. Faster, they're more efficient than strings. We also have data types for IP addresses. Again, faster than strings. So use them if you have that data. Low cardinality is awesome. It really is. We throw around this number of 10,000. If you have a column with up to 10,000 unique values, we recommend you use low cardinality. Take that recommendation and run with it. Absolutely. Try 20,000, try 50,000 unique values. See if it's faster, because low cardinality, storing strings as numbers, is always going to be faster. This one doesn't always help, but you come from a relational database and you're so used to just joining this and joining that and joining everything on this and the other thing and all of it. And look, in ClickHouse, in these big data systems, we just grab the data and join it once at insertion time. That is super common. So sort of think that through in any situation. If in Oracle, to have 10 tables all related to each other, like, people go out of their way to design that. They think it's all clever and great. In a system like ClickHouse, it's neither clever or great. It's better to just have all that data joined ahead of time. So think about that as you design your tables and your systems. Materialized views are great. Like I said, make sure you understand how they work, but they are super nice, especially, like I said, if you have a dashboard and you're running the same aggregation over and over again. Look into materialized views. We have a whole training on that. If you didn't go through it yet, make sure you check that out. And in that same training on materialized views, I mentioned regular views. Don't get too excited about regular views. They have their place and time, but they're not that efficient. They're actually inefficient because ClickHouse can't take advantage of certain optimizations. And so they can actually slow things down. I love the explain command. I love that we used it here in this particular training already with both projections and with skipping indexes. It's a nice thing to know about. It's nice to watch the query execution plan. These are simple queries, but if you get a pretty complicated query, it's nice to break it down. You might be able to figure out what's taking so long. This one can happen once in a while when you start up ClickHouse. Now, not in the cloud, because you don't have to worry about these things in the cloud, but if you are running ClickHouse on-prem, if you ever see a read-only mode, I can tell you right now, it's because your keepers, your ClickHouse keepers or your Zookeepers, you don't have enough of them running, or they're not running at all, or they can't be found. Something's wrong with ClickHouse Keeper. So keep that in mind. That's not a common error, but a common error that you might see once in a while. And one more very low-level detail. If ClickHouse doesn't start up properly, there is this folder. I'm going to exit out of here and show you the folder structure. I haven't done this before, but if you go into the data folder, wherever that is on your system, you'll see here I have 3 folders. Well, these look like my database names. Well, they are my database names. And if I go into default, you'll see, well, I don't have anything on that one. Oh, I was connecting to the cloud, so I didn't have anything here. Let me go to here. This will take a second. Sorry. Let me try this. I got a bunch of tables in here and databases. Yeah, if I go to default here, and you can see all my table names. I have a lot of, 90 tables or something like that. And if you go inside one of them, if I go into UK price paid, you can see my part folders. You can see that I only have one part, and the name of the part is, I don't have partitions, so that's what the all means. This is blocks 1 through 28. I've gone through 2 levels of merges, and if I go inside there, I'll see my files. I'll just do a ls. You can see the names of my columns with the bin files. This is the column storage. you can see a file called count.txt, which shows you how many rows you have. That's pretty clever. There's another one in there that kind of explains the, columns. If I do columns.txt, you can see almost the schema in a sense. Lots of nice information in there. What I really want to show you is this. There's a folder in here called metadata. And inside there, did I go to the right folder? Yeah, there's a bunch of SQL files in here. Let me just do a ls. Whoops. There we go. These look like, same deal. They look like folder names that match my table names and my database names. And if I do a ls, every single table that I have, there's a SQL file in here. And if I cat UK price paid .SQL, you'll see that what's happening is at startup, the tables are getting attached. It's how come your tables exist when ClickHouse starts up. If you're having a problem with a table, you can go in and delete or remove or move the attaching of the table, especially if there's something wrong with that table. So that was kind of my tip here, along with some other tidbits that I shared with you. All right, nice lab. You're going to define a skipping index on UK price paid, and then you're going to define a projection on UK price paid. These are fundamental concepts in ClickHouse, and I think it's really important that you understand how to use them. All right, if you need help, have any questions, be sure to find us, clickhouse.com/Slack, or you can send us an email, learn@clickhouse.com, and off you go. Good luck.